I'm Carl Rehn. I'm the CEO of Pascal Technologies, and we work with energy efficiency solutions for boats. The company is actually an old R&D company that was taken over in 2020, and I was the first employee. And for a long time they had for a long time been working with these surface effect or air lubrication solutions, and we really saw the opportunity to take that into the electric boat space now, and we see potential to double the range for electric boats. So that's really the short story about what we do, and we partner with boat builders and motor companies to deliver a good end product to the customer. Yeah, the technology is actually old. As with hydrofoils, it's from the typically, like people say, it's around the Second World War, and has seen variety of forms and shapes. It's not typically been that much focus on electric until recently, which is really where you're starting to push physics to get long range, as you can see in the EV automotive industry. But the technology, core technology, surface effect chips or hovercrafts, is another family, right? You have conventional hulls, you have hydrofoils, and you have the air family, which comprise of hovercrafts, right, where you have a big rubber skirt around the whole boat, but it's not like a boat, it's more like a flying sausage. Difficult to kind of control with directional stability, but it's very, you can take them on land, for example, and water. And then you have surface effect chips, which are typically with a catamaran hull and then a mix, so it has a rubber skirt and bag on the back and front. And then Norwegian Navy has several of these, and they're on diesel, and they can go very far and very fast on diesel. So that's, I mean, the Navy uses the technology for its performance characteristics, while we think this monohull variant of the technology is very applicable to small planing crafts, and that's primarily what we're focusing on right now with leisure and commercial. There are three classes of hull types, right? Conventional, hydrofoil, and CES, surface effect chips. And we are working with the CES solution, and it looks like a regular boat, but it's just basically air lubricated. Like if you have played air hockey before, when you turn on the air, it glides with very low friction, right? And if you turn it off, it stops. And that's essentially the effect that we try to reproduce here. And in contrast to hydrofoils, we are very flexible with regard to how we can scale with different boat builders, with different propulsion types. This is a conventional electric, if that's a thing, outboard that works perfectly together with our technology. So we're flexible. We can have shaft, we can have inboard, we can have outboard, we can have water jet. So we can offer our solutions to a very large share of the market. So we can take our technology and work with many partners. And I think that's key to really like helping this segment go zero emission faster. While here it's more of a conventional boat. You cannot see this boat on the water, so we have brought a model. It's the same boat approximately, 3D printed. It looks like this on the underside. So you have the fan blowing air in here, and it's like a mix of a catamaran and a monohull. But in contrast to catamarans, you have a very large space in the middle underneath. You can build in like a conventional. It has a lot of volume on the inside, and it plows the water like a monohull. And we blow air in here from a fan with inlets in the front, and it covers this section in the middle with air, and that's about 70% of the boat's wet surface area is then reduced. And then we have a flap in the back that we close and open depending on the case or situation. And then this print doesn't have any motor on it, but here you see we just have a conventional outboard on our prototype now, and we have also worked with other propulsion solutions including pod and stern drive. If everything else is kept equal, we see that we can reduce the energy consumption by up to 30 to 50% approximately. But it's quite difficult to compare often because you have to have the same propulsion system. Weight of the boat is extremely important, but that's about what we see. We can push this one up to 45 nautical miles of range now in planing in 20 knots, which is about 2 hours in planing speeds. That's about typically monohulls of a variety of boats. They are typically around 1 hour in planing speeds, and we can do 2. And efficiency is extremely difficult to do with the. I mean, efficiency on boats, mainly three things. It's the resistance of the boat in water, which is what we primarily address, and then you have the driveline efficiency, which is what Tesla is extremely good at. It's all about losses in the inverter, in the electric motor, in the mechanical transmission and the propeller, and that's also extremely important to really not screw up. And then you have the weight of the vessel, and it's if you can reduce the weight by 50%, that's 50% reduced power. So there's a lot of factors here, but in total we are about 50 to 100% longer range using our technology compared to a regular boat.
How did you find yourself as the CEO of a performance hull boat company?
That's awesome. I'm an engineer. I really like. This is quite complicated technologies, but we're working in a space that's luckily a little bit more regulatory easy than, for example, airplanes and rockets. So we really see like rapid innovation and hopefully quite quick. We are working with several projects now, and we're expecting quite rapid go-to-market penetration going forward. So it's really cool. It's not like we maybe have a product in the market in 2030. It's like this year and next year already. And it's like less than a year from drawing to a working prototype if you start with something new. That's also very rapid compared to, for example, aerospace industry.
Who's making your hulls? Your company is doing that, or
we are selling engineering and some components and software to boat builders, and they're building the boats as they always do.